Good afternoon. How are we this fine Monday rainy day? Fantastic, I can tell. Welcome to the session on Archivematica, creating a comprehensive digital preservation system. My name is Jim Cassidy, and I'm the brand newest co-chair of the Technology Applications Committee. We sponsor programs especially on relating to automation in archives and workplace applications of technology. I should mention that the National Archives Assembly, which is pleased to co-sponsor this event, is an organization of current and past employees of the National Archives who seek to learn of new archival advances while at the same time advocating for a strong National Archives. It is my great pleasure to introduce Dr. Kenneth Thibodeau of the Electronic Records Archives. Ken has asked me to say a little more than that he too is an old fogey, but he has a far more distinguished record than that. And certainly his service with the National Archives is notable, and I am happy to introduce Ken to introduce our speaker.
Thank you.
Thanks, Jim. Good afternoon, everybody. A lot of people don't know I'm really a closet teacher. I started my career as a teacher, so I love pop quizzes, and I'm going to start today with a pop quiz. What do you get when you cross an archivist with a geek? The answer is you get today's guest speaker, Peter von Garter. Peter's a graduate of the Archival Studies program at the University of British Columbia, and he's currently working for his doctorate in archival science at the University of Amsterdam. But he also has a certificate in software engineering. In fact, in addition to that cross, Peter has another cross in which he's both a Canadian and a Dutchman. So you get the combination of the Canadian laid back and the Dutch habit of speaking fast. In fact, I don't know anyone
And loud.
who speaks faster than Peter. One of my other Dutch friends point out, well, the reason for that is if you have a country that exists below sea level, you want to talk fast before you drown. But anyway, it's a pleasure for me to introduce Peter today. We've worked together for more than 10 years, starting with the first Inter Pares project, where Peter had some involvement as a student and as the project manager. And I don't want to, Peter today has what I think is the best job title in the world, President and Chief System Archivist. Not system architect, but system archivist. I don't know if there's anyone else in that has that job description, but from a company called Artifactual Systems that does development and consulting services in the IT area, specifically primarily for libraries and archives. Among other things, Peter's company has developed some software called ICA Atom, which they're doing for the International Council on Archives, which is software for description that conforms with the ICA standards on description, the ISAT-G and ISAR and so on, and other products. But I don't want to take too much time up of Peter, so I'm going to turn the mic over to him.
Great, thanks, Ken. Thank you.
Peter did ask us earlier to encourage you, if you have questions or comments, interrupt him at any time.
Yeah, I prefer just to have a discussion while we're talking about stuff. So please raise your hand and let's discuss. And I guess we got an hour and a half or an hour and 20 minutes now. So I'll get right to it. But first of all, I want to thank Ken very much for extending the invite, and as well to the National Archives Assembly for asking me to come and speak. So what is Archivematica? Before I do that, I understand all as well there's people following along from a webcast. What I'm doing right now, I'm actually running a virtual machine on my laptop. I'm running the Archivematica system from a USB key. And unfortunately, that means that I'm not able to use the web conferencing software to do a presentation. So anybody that's listening on the telecon, I've been told you've got these links already. I don't know if there's the presentation slides, the workflow instructions, as well as a whole series of screen captures from the system. So between all of that, you should be able to kind of follow along and see what we're talking about here back in DC. So Archivematica itself is an integrated suite of completely free and open source tools that allow users, typically archivists, to process digital objects from ingest to access and apply format-specific preservation policies. The Archivematica project 2 adopts a agile software development method, which one of the key components of that is having time-based release schedules. So we release no matter what on this date. Whatever we've got is what goes into that release. And so it forces a certain discipline in the software engineering process. And what that means is that we've had 6 very rapid iterative releases already over the past 14 months, leading to the 06 alpha release, which was done last week, about a few days ago, and that's what I'm demoing to you today. Each iteration in an agile development method leads to improved requirements, obviously improved software, as well as updates to documentation, improving the depth and breadth of all of those, as well as development resources, the resources that are available to developers and people working with the software. So the big part of that is that we're not going to get it right the first time. We just pretty much assume that, and a lot of, it's basically the exact opposite of this. It would be a waterfall methodology where you try to get all your requirements just right. You spend a year writing a giant spec document, and then you go and try to make it perfect the first time out. So the agile development methodology really is, and I think it's very well suited to the digital preservation field, where for all intents and purposes, we're never actually going to be finished making our system because the technology we're trying to preserve is constantly changing, and the technology we have available to preserve digital objects is constantly changing. So we try to just accept that right from the start as a principle. Where did it come from? Ken mentioned my company, Artifactual Systems. I've been consulting now for about 10 years after Interpares, worked on the Interpares project, and that's where I met Ken. I went and started my own consulting business, doing electronic record strategies, digital preservation strategies. But more and more, I became very interested in the opportunities and for open source software to be used in archives for a number of reasons, which I'll come back to at the end of the talk, which I think, a number of reasons why I think open source software is a good fit and a right fit for the archival community. So over the past few years, the main focus of the company has been developing and supporting open source software tools for the archival community, ISAATM and Archivematica in particular. City of Vancouver Archives is one of our clients, and they essentially started on the path as one of the smaller, like a city, a medium-sized archival institution essentially, wanting to implement a digital preservation solution because of the same problem that all archives have. 90% of the world's information over 90% is now being produced in digital format. That's tomorrow's archives. Tomorrow's archives are here today. We've been creating them for the last 20 years. Unfortunately, a lot of institutions don't have very practical solutions in hand yet. They don't necessarily have the budgets of a NARA, let's say, to go and implement an enterprise system. So it was a very practical need to transfer records from electronic records document management system, as well as now to transfer over the electronic records from the Vancouver Olympic Organizing Committee. We need to be able to do something now, like what can we do today? So with that in mind, about 2 years ago, we started with the premise that there's enough open source, there's been a lot of research. I mean, Interpares kicked off in '98, I guess, and well, if you count the UBC project, but there's been a lot of research around for a long time, and there's also been a lot of one-off ad hoc tools been created over the last few years as well that let archivists deal with certain particular parts of the pieces of the digital preservation problem. But nowhere, if you're a small, medium-sized archival institution, could you say 2-3 years ago, here's something I can plop down and start doing OIS-compliant digital preservation today. Part of our theory was that there's enough of these tools around, we should be able to stitch them all together to create one comprehensive digital preservation system. And that was actually the premise of another paper that was published shortly afterwards by the UNESCO Memory of the World Subcommittee on Technology, which essentially had the same premise, saying that there's enough of this around, can't we put all this stuff together to try to make a free and open source archival description system, archival digital preservation, digital archive system. So over a period of time, we got in touch with the UNESCO Memory of the World Committee, and they became a sponsor for this project as well, to take the technology we were developing hand in hand with the City of Vancouver and open source it and make it available to the archival community. Another client of ours, the International Monetary Fund Archives, was on the same track as the City of Vancouver and going through a digital preservation strategy, and essentially over the last half year has been working with us to do a proof of concept project using Archivematica and contributing back to the Archivematica code base as part of the time and resources we're investing in it, to essentially work out their full spec of requirements. So doing an early iteration essentially as a proof of concept project to get ready for their own full implementation of a production-ready digital preservation program. So I mentioned the OIS. Presumably everybody is familiar with the OIS model. I don't have to go into any more detail for it. The key concepts there, again, it's a default language. We talk in the digital preservation world, and it's the default language we use within the Archivematica project. The key concepts are the mandatory responsibilities, the functional entities, the information packages, the submission, the dissemination packages, and the archival information packages, the content information, the preservation, the description information packages. And then the actors, the consumers, the producer, the management that plays certain roles within the system. We focus specifically on the functional entities as the things that describe what an OIS system needs to do first. And this is typically, the high-level OIS diagram you see when people talk about OIS. Of course, when you drill down into each functional entity, it gets a lot more complicated. And who has actually peeled through and read OIS from beginning to end? Okay, so don't. Well, people that work for Ken will have. So it gives me a good idea of who the audience as well. Then, so it's a beast. Like there's a lot in there. It's a great standard. It's really been one of the major advancements. One of the first things we needed in the digital preservation community, so we could all start talking the same language, put everything in the right box in the right place, and figure out where components are going to integrate. But the standard itself is not perfect either. There's lots of inconsistencies when we did our analysis, and there's just a lot to it. So we need to be able to filter this down, to create a simple system to be able to say, in order for us to be OIS compliant, which everybody wants to be, what do we have to do? So we started by, first of all, using a use case methodology in the City of Vancouver project, and breaking down each of the functional components and doing a detailed use case analysis, breaking it down hierarchically to figure out what comes in, what goes where, and start translating the language a little bit to something that's more practical and that fit more standard archival business processes. Those use cases then weren't enough. They were still too abstract at that point. So then we started developing UML activity diagrams, which is this very specific workflow methodology. And those actually went through 3 iterations as well, because the pure adaptation from the OIS model still was too abstract for us to be able to apply it directly to match the requirements of the archival businesses processes at the city archives. So the 3rd iteration is one that we could use as the baseline system requirements for development, and that's what we've been using over several iterations of the software development now, and it gets updated each time we do the software development, because again, the actual deployment of software, trying to integrate it into some case studies, use case studies, inside the archival institutions, and the limitations of the technology itself as they exist today in 2009 and 2010 actually influences the requirements, because it'd be great, theoretically we can say it'd be great if we can do this. If we can't do it, what's the point? So it really is, the focus using our agile methodology is really to be as realistic and as practical, as pragmatic as possible to get something working today that still meets best practices and standards. And in each system release, then we end up with a set of system workflow instructions that essentially take these functional requirements, which say specifically what the system needs to be able to do. And because we don't necessarily have all the technology isn't mature, it isn't necessarily fully integrated yet. There may be technical gaps, there may be simply development gaps we haven't had time to get to yet. But what we want to do is be able to say, even with our very first iteration 1 proof of concept, we were able to identify specific steps that either a technical tool or an archivist performing a manual step would complete, so that from point A to B, we would have fulfilled all the OIS requirements. And that's really for us is another critical principle in the project, that the system is not just technology, it's an integrated whole of people, procedures, and software. So that with every iteration, we're confident that if that's all you had, if the development stopped today, the archivist could still take those instructions, take that technology, and complete OIS, SIP processing, get an AIP, get a DIP out to the consumers, and still be fully compliant with the OIS functional model. So this is the latest set of the workflow instructions that's available for download. I see somebody photocopied a page or 2 of it as well. And this is what the archivist or the user would use to then follow along and actually complete the steps within the system. With the white boxes being the automated steps and the blue ones being the manual steps. The color's a little bit off here. So we took each of the steps in the process and we mapped them. We essentially made them what's called a microservice. So the microservices approach to digital preservation is turning out to be quite a legitimate and quite effective alternative to a large repository. Is that somebody's phone? Is this your phone? Is yours your purse? Oh, the battery's low. What was I saying? I was saying that the microservices approach is turning to be quite an interesting and I think very effective alternative to large-scale repository-based digital preservation systems, where the system is built around the capabilities and of the technology stack first. It starts with the repository stack. It starts with the essentially the framework stack, which almost always is J2E, like JBoss servers, that kind of thing, and then works its way forward from there, saying this is the technology we have. How are we going to meet the requirements? Alternatively, the microservices approach says these are the actual granular things that need to happen along the way in an OS workflow, and here's some tools or here's some manual processes we can map to that to get this job done. So this is over the last couple of years, the California Digital Library has been doing a lot of work to kind of standardize the microservices approach, and they've published a number of specs in collaboration with Library of Congress as well. And I noticed recently iRods itself, one of the research collaborators here with NARIS, has also started to define, which again, it was one of those things where we were already doing it that way, it just didn't have a name yet, and iRods was already doing it that way as well, it just didn't have a name yet. Now we've got a proper name, we've got a lot of theory around it now that helps us kind of essentially establish it as a legitimate alternative to repository-based digital preservation systems. Okay, what does that mean? We just grouped all our
Peter, question.
Hi.
Yeah.
Hello, testing. I was just wondering, this seems to be a nice microservices idea, and it seems to be a nice implementation of modularity in the system. How much have you guys tested that as a proof of concept in terms of swapping out different tools for the various microservices?
It's working out quite well so far, and thank you for bringing that up. That's one of the key principles is the idea that we're not married to a giant technology stack, so that if we have one tool providing, say, normalization services, or providing unique identifiers, and if that tool, for whatever reason, we have a better tool, or that tool has limitations, we should be able to swap it out of the stack and put a new one in, and carry on processing like we did before. And that's, we already had that with Xena. Xena is a normalization tool put out by the National Archives of Australia, and our very first iteration we used Xena to do our normalizations of Office documents to open Office format. And there was certain limitations with that tool that we just weren't happy with, and we ended up actually swapping that out over this last release and putting in using it's called a Uniconf. It's a service engine that uses the Open Office engine directly. So Xena was using Open Office as well, but it introduced a whole bunch of layers and wrappers around it that wasn't really working with our workflow. So in fact we did that. We pulled out Xena and we dropped in Uniconf instead. So, and that's one of the beauties of the microservices model. And we did it like in 2 days, like with a bit of testing and so forth. So this is definitely one of the, I think one of the strengths of the microservices approach, and it's particularly for our problem domain, digital preservation, where again, the technology that's creating the digital objects that we're ingesting, and the technology that's available to us to manage that stuff is constantly changing. And essentially what we're trying to do with the Archivematica project is not just develop software, but develop a kind of a methodology that the microservices helps us kind of define that theoretically, but practically as well, we want to develop a methodology that makes it very easy for us to constantly be adapting to that change. So what Archivematica is then as a system, it's again, the California Digital Library guys just did a great paper they're going to present at the Open Repositories in Spain in the summer, where they talk about the Unix pipeline metaphor. And this has been around for a long time already, since the 70s. It's this idea of the Unix pipeline is essentially you take the standard output from one process and you make it the standard input for the next process. And that's essentially what Archivematica is. It's a classic Unix pipeline of OIS-defined microservices. And we map, you see the microservices at the top there. Each of those is mapped to one of the existing open source tools that we've integrated into the application. If you go to archivematica.org/software, it'll give you a listing of all the tools that are in the current release, as well as a link to all their licenses, because of course we want to make sure all the licenses are compatible so that we can continue to give the entire system, the entire stack, away fully free and open source. And so we've got digital information objects working their way through the various microservices workflows and simply being passed on from one process to the next using standard Unix pipeline approach, where we've got a combination of Python scripts and Bash scripts that simply move the stuff along, queue it, make sure it lock it so that we don't get clashes in the pipeline and so forth, making it possible, again, to run the entire system from a USB key. For demonstration purposes, obviously, a 4 GB key is what I'm running the software right now. So what we end up doing is we end up bundling. We've been working with the Ubuntu operating system. We went to a specific flavor of it that uses the XFCE desktop called Ubuntu, but it's essentially the full power of Linux, the Linux operating system that we're building and integrating this off of. It gives us a nice user-friendly desktop to work from. And we're bundling all these tools on top of it, and we're allowing the user to come in and bring in their digital objects externally. So either from a network directory, like the DoD standard, for the DoD standard requirements, the 501.52. What is it? Yeah, did I get it right? Is that right? 15. Okay, you know the one. It talks about having transferring records, making them available in the network directory. So Archivematica would have a watch directory. It would see the submission information packages appear in the network directory, and then the archivist or the system would pull them in and start triggering and trigger the workflow process. Or what we're doing in City of Vancouver, for example, the VANOC records, they don't want to give us their servers, so we have to go in with a bunch of 1 terabyte hard drives, use CRC tools to, we're using rsync to get the stuff off of their drives, confirm that we've got it on the hard drive, bring it back to City of Vancouver, plug it into a transfer station, and use the external hard drive to then move it over and kickstart the workflow process. The entire system is packaged as a virtual appliance that combines all of this. So we've got the operating system, we've got all the tools, we've got our integration code living as one system. We can make a virtual appliance that runs inside a VM player, like VirtualBox or VMware, so we can put it down on servers. At the IMF, for example, it's running off of VMware servers. I can run it off a bootable USB key, like I'm doing now as a demonstration system. But even for if we can make much larger USB keys. So I'm planning a little project on my holiday to do my own family digital archives using a completely USB run system. We can then also go to dedicated PCs and servers. So at the City of Vancouver archives, they're actually more this setup here. We've got about 5 or 6 workstations now that are networked in a totally private area network, so that there's no issues with security with external records coming in until they're actually ready to go to the network storage. And we're able to use the same disk image that we used to create the virtual appliance and the USB key as a completely bare metal install on the machine. So it just, here's a machine, boom, we install it on there. It's got 4 gigabytes of space. We blow it up to a terabyte that's available, and now we've got a fully ready functional Archivematica node. And then we can connect various nodes over the network. So we use that to replicate itself over the network. And then we can, the archivist, there'll be 2 archivists working at the beginning, so they can do their own SIP processing at a time, but they can share archival storage, they can share the access system via a network connection. That's all happening from the same virtual appliance. Okay, so when the user boots up from the USB key or starts the machine that it's a dedicated Archivematica install, what they're going to see is a desktop. And again, part of our agile iterative approach was that we need an interface to this thing. Well, we can use the operating system, and we can use a file manager as the initial. We're moving files through a pipeline, so a file manager makes a perfect user interface for this. And so we've got a number of scripts embedded in the OS and inside the file manager to help the archivist move stuff from one place to the next. Over time, as the system becomes more sophisticated, a lot of this will actually move to a web-based dashboard, and we're already starting to develop that right now. So the archivist primary interface will become a web-based dashboard, but for the time being, the archivist works with the desktop interface. So the first folder is the receive SIP folder, and this is a watch folder. You notice the arrow, that's just to simulate the idea that if this is a live system, we have it watching a network directory through a CIF share or an NFF share, WebDAV, HTTP. There's a number of ways that we can watch external directories and have the notification come up to the archivist when a SIP has arrived, either from the external media or from a network drop. So here I've got 3 sample SIPs, and we only have really time to go through one, so I'm going to go through the one that's got a little more detail to it. And so here, the use case we're simulating here is a submission information package coming from the electronic records document management system. So it has its retention schedules, every year, every month, it has a number of records that come up for archival preservation. Those the system exports and puts in this specific drop space. The other examples, images, multimedia, maybe the archivist has gone and done a retention evaluation of the shared directories. I mean, that's one of the first places these types of pilots typically start before we go to more sophisticated system integrations and so forth. So the archivist makes a copy of the SIP. And that's, of course, is, for example, the City of Vancouver, we have two backups, so that if anything happens during the processing, we can go to one of the external copies, or we can go to another backup copy, because we're not going to sign off and destroy the SIP until we're happy we've got a fully ready AIP and DIP loaded to the access system. So SIP, Submission Information Package, that's the package that comes into the system. It gets converted into an Archival Information Package, an AIP, or what we call AIPs. And then the Dissemination Information Package is the information package that's made available to the end user, and that's we call it DIP for short. And all of them are essentially a combination of the actual digital objects and the bit streams, as well as any metadata that describes either technical metadata or descriptive metadata. The combination of the two make an information package, and depending on where it is in the process, it's either a SIP, an AIP, or a DIP. So they come in as SIPs. And again, keep in mind this is designed for archival business processes. So we have a review SIP step where either the system at some point, at some future iteration, will actually go and check the manifest to make sure it's compliant with the submission agreement that they've established with the producer. Or the archivists themselves can do a check and make sure that the metadata they were expecting was the right kind for this type of system transfer. We do an MD5 check on receive to make sure that the files weren't corrupted between transfer. So here, for example, is we're starting the SIP metadata, descriptive metadata with essentially qualified Dublin core. So in this particular scenario, we say that the electronic records document management system gave us some metadata that we've mapped to the appropriate Dublin core elements. If the system didn't come with the metadata at this stage, then the archivist could right-click and add a blank Dublin core XML template. Which then they would fill in with any descriptive metadata they have. We expect to add EAD as an option, and we're very likely going to have some kind of, we're looking at some other projects that have basically, like the California Digital Library, the Tipper project. Essentially, qualified Dublin core doesn't give us enough elements to capture everything we'd want to handle transfer and appraisal. But then the other option is, of course, at the City of Vancouver, they use the TRIM document management system, and it gives us a whole bunch of metadata. A lot of it is quite useful, obviously, for description and so forth. And so what we do is we'll end up taking the custom metadata that comes from whatever target system there is, and we'll end up bundling that as well in what ends up being a METS XML profile. So for all intents and purposes, we'll say that this one checks out and we're happy with it. So we move the SIP to quarantine. Now this is a practice that we've adopted from the National Archives of Australia, and the theory being that when you take in a bunch of records that have been transferred, the very likely could be a bunch affected with the virus. If you, but the typical virus tools don't have the definitions updated until a few days later or a few weeks later as the threat becomes known, and they put a patch in for it. So the idea is that, let's say, I think in National Archives of Australia, they've standardized on 30 days, so you put your stuff away for 30 days. When it comes out, you run a virus check, you update your virus check tool, and you run a virus check on it. Assuming everything clears, you start processing your records. So that's a step that we've incorporated into Archivematica as well. For demonstration purposes, it's just set to a minute right now, so it's crunching away. And as soon as the minute's up, it's going to start preparing the. It's going to start processing and preparing the SIP for appraisal. And so what it's done already is it's assigned a unique identifier. Obviously, we have to have a unique identifier assigned to all our information packages. So to the package itself as well as all its contents. There it goes. It's just finished quarantine. So now it's starting appraisal. Notice it says quarantine completed. And now it's extracting packages. So one of the things we found in very early iterations is that you end up using lots of zip files, and you don't know what you're going to get when you start pulling stuff off a shared directory, for example. And part of our design goal is to be able to handle anything that gets thrown at it. So one of the very practical things we have to do is clean up file names and extract packages. The other thing is you have ampersands, weird combinations of characters that are prohibited in Unix, where we're running all these tools. So we do a cleanup of the file names. Of course, we keep a log of any file name changes that we're making. So our unique identifiers that we're using are UUIDs, universally unique identifiers, which we think is a very simple and elegant solution to the identification problem. There's been a lot of effort put into creating global registries for unique identifiers, and I think using UUIDs is actually a much simpler, more elegant solution. It's an algorithm that's, again, it's available as a standard Linux utility tool. It's available for every programming language available. It's an algorithm that makes it very, very unique number that's very difficult to replicate. And I've got a little quote there. It's something about, well, you see it. It's very unlikely in our known space and time that we're going to create a duplicate UUID, which totally eliminates the need to go register it somewhere globally. Because if I use this tool to create a UUID over here, if you're creating one over there, they're going to be unique. There's no point. It's not going to clash. Then we can use things like archival resource key to put namespaces on it and so forth. Okay, so the appraisal just finished. You saw the notifications popping up as it's going through, and we'll take a look at it in a second. One of the critical things we did was after we did assigned a UUID, we checked the checksums to make sure whatever got sent to us is actually what we received. We extracted packages, we cleaned up file names, and then we started identifying, validating, and extracting metadata from the digital objects. So this is one of the places where the actual practical tools first started to emerge about 5 years ago. There was the project started at Harvard, I guess, was Jove. The National Archives of the UK had Droid, and the National Lab of New Zealand had a metadata extractor. And these are tools that were, the whole purpose is to do identification validation. So yes, you sent us something called blah, blah, blah.mpeg. What is it really an MPEG file? Is it really .doc? Is it really a Microsoft Word document? So what these tools are designed to do is actually look at the bit streams, look at their headers, and say, yes, this is in fact this is a document, and then validate it against published standards to say, yeah, this particular document actually meets the spec, and it is a valid Microsoft Word document. It's a valid MPEG file. And then typically most digital objects have a lot of embedded metadata that's either explicitly in the header or we're able to pull out using certain tools. So there's a whole wealth of technical metadata that we can pull out of existing digital objects that can help us with arrangement and description, with just authentication and so forth. And of course, digital preservation to tell us what the file formats are and what we need to do with them. It's low resolution there. So the very first iteration of Archivematica was essentially taking these tools, which is one of the things with most archivists that have been involved in digital preservation heard about these tools, but it was just actually getting them installed. Usually they typically have a Windows desktop that's locked down by their network administration, and so they can't even get their hands on the tools. So our very first goal was just get these tools on a platform. We made a live DVD so you can pop it in anywhere and work with it. So archivists could actually start working with the tools they've been hearing about and going to conferences and hearing about. And so we did the same thing and presumed that this is going to be able to give us the very first step in the process. We can do identification validation. The problem we ran into, and this is all on the Vancouver Archives Project Wiki, and there's a test set of about 30 different file format types. This is only the first 4 or 3. We found very, very conflicting results between all the various tool sets. And the end result is that they're all very early stage tools still. They're all excellent projects, and they're all trying really hard with the resources they have. But they're actually not necessarily very reliable quite yet if you compare all the various test results. And this is actually a real problem still, I think, in the digital preservation domain, is getting good, reliable identification, validation, and comprehensive. That's the other problem. We can target a few specific file formats, but to get all of the thousands of potentially known file formats that we're going to have thrown at it to be able to identify, that's just a logistical problem. So we kind of hit the wall on that one, and fortunately out of nowhere came what I think is probably the most underrated digital preservation project out there today.
Peter?
Yeah?
Mark, somebody online has a question. Mark Conrad.
Peter, I'm looking at your slide, and you say that these services validate the format, but at least in the case of Droid, all it's doing is doing string checks within the header. Do these other tools do actual validation?
No, not very well. And I think the file tool does, but you're correct, Mark, and it's really only doing it, it's trying its best at identification. And validation, for us, the de facto validation is happening when we throw it through the normalization tool, because the normalization tool will either choke or it won't. And for us right now, that's the only real reliable way to do validation. So you're correct in that it's really only identification that's working, but although the tools profess to do validation, right? And it depends on the file format. Again, I think there's a very limited set where they will validate. But again, that's a known limitation of this whole area this whole toolset area right now.
Okay, thanks.
And your experience is there a tool that does that properly right now?
There are individual tools for individual formats,
Exactly.
but that's it.
Yeah, exactly. So that's the problem. And so I think FITS is a really, really good start. Are you familiar with FITS, Mark?
Yep.
And so I think this is a really great start on starting to solve this problem. And essentially what it's a lot like Archivematica. It's a wrapper around existing tools. And what it does is it takes the best practice tools we have so far, as well as integrates a few other known Unix utilities that do this kind of work. And what it does is it'll output a report, which is what's happened here after we fed them through FITS. So for each file, we get a FITS log report, and it essentially reports on the various conflicts. So it tells us what each. First of all, it tells us if there's consensus, and quite often, but unfortunately, quite often there's not. And again, these tools are still very raw, and sometimes it's very simple problems. It's like one using it's just a namespace issue, like where you're not using the correct file extension and so forth. And so the two consider them to be two different things. There's issues with identifying the correct version and so forth. But it does actually, in the end, what it does, it takes all the output from all these tools and publishes in a report. And what you can do is you can go to the FITS tool and tell it, I trust this tool more than the other, or I want to base whatever I do, I want to give this tool a higher ranking, or I want you to use this tool last to evaluate the conflict and use it as the deciding vote. So it gives you more flexibility in mixing and matching, but we haven't gone really that far yet in doing that. But it certainly is, to my opinion, is definitely the way forward, and we're relying heavily now on the FITS project, which is in very active development. There's a lot of work being done to it. And this is out of the Harvard University, and I think it saved our butt because we had a serious problem with how do we go forward. We were at the point where we're going to have to develop our own FITS tool. But of course, this is the beauty of the open source model. Somebody else has gone, made it available as open source, and boom, we can integrate it to our project, and we can move on to other things like finishing the workflow automation.
Peter, we have another question.
Okay.
Richard?
Yes, can you hear me?
Hi, yes, no problem.
Hi, this is Richard Marciano.
Hey, Richard.
I had a question regarding your workflow framework. Since you describe it as being sort of a generalization of Unix pipes, typically that means that there's no state or global state information, that you're passing information from the previous stage to the next stage. Could you comment on that and say a little bit more about how all these tools actually coordinate, and if there's any notion of state that's built into this framework?
Yeah, the state is captured in the log files. So, the state of the actual digital object never changes, right? We will normalize it, which means we make a copy of a brand. I'm talking to a box here, like your disembodied voice coming from a black box on a table. The digital object never changes state, and that's the whole point. We want to authentically preserve it. The only time it changes state is when we make a normalized preservation or access copy of it. All the things that are happening to the object and all the information we're able to pull out of it, and again, all the things that are we doing to it, those are being captured in log files. And in fact, that's if you look at your screen captures, there's probably a couple of shots of the log file directory, and including the FITS output, including things, the log for when we extracted things and so forth. So, that later on gets embedded back into a METS document. It was still working on getting all of the log file into the METS document. But the standard input-output is that we pass the output typically is the file, and then we pass it on to the next process where something either pulls information from it or does something to test it. Or in some cases, again, I guess I lied. We do change the file name, so you could argue that's a state change. But typically, I guess the separation is that the object just keeps getting passed through the pipeline, and the actual information about things that are happening to it are being captured in the log file. Does that answer your question?
Yes, thank you.
Okay. So here's a log for the UIDs that are being assigned to the objects. The MD check, the virus scan. So I didn't mention either that we were using the ClamAV tool, which is being run on most, I think the majority of the email servers worldwide right now to, essentially because a lot of people pass attached documents, so it's a big problem with viruses coming through email servers. So it's a very active and, again, fully free open source project. So Archivematica, as long as it's got an internet connection, it's constantly pulling down the ClamAV virus definition updates. Okay. So our next step is the archivist now has all the information in front of. Oops, I closed the. So another step in our workflow now is that the archivist is getting ready to appraise the SIP. So again, it could be business rules that say don't bother if it's coming from this kind of system, or the archivist could actually manually go in now and take a look at the objects. They know there's no virus issue. Again, the virus issue for us is it's almost like a feel-good factor for us. It's more of an issue when we pass the object back to the consumer. Most of the viruses that are being written aren't going to be an issue on the Linux system that we're using to manage Archivematica. It's got to be some pretty tricky viruses to actually cause a problem for us inside the system. It's more an issue and a courtesy not to pass infected objects onto the consumer if they ever ask for an AIP with the object in it. So the objects have been virus checked. We've pulled as much metadata as we can about it. That information is available right now in the log files. And at this point, the archivist could make decisions about whether certain objects actually meet their appraisal requirements for historical value, for informational value, for legal value, or they could assess the technical capabilities of the archives to preserve, whether they're happy with the default normalization policy that's going to kick into effect, depending on the file formats that were identified, whether they want to change those at this point. Any number of things could be happening at this appraisal stage, depending on institutional policy. One thing we didn't do is, one thing we're leaving as optional right now is if we unzip the zip files, so you notice here those got extracted. But we kept the original zip files as well. So here's an example of where I might say, okay, well, as a policy, we don't actually want to keep those. We'll trust that the extraction worked properly. And you'll notice that there's a manifest for the SIP itself. And here's where we're starting to assemble all of the information. The descriptive metadata that came along for the ride in the Dublin Core XML that was included is in the descriptive metadata section. We have the AMD and file section describing the actual contents of the information package. We have the starting bits of inserting premise metadata into the administrative metadata section. In this case, the UID and original file name if the file name was changed. And something for 07 is to get all of the log metadata into premise events is a major deliverable for us that we're working on an 07 release. So I'll take the, let's say I'm happy with it as is. So I'll drag the Office Docs ZIP and move it over to the Prepare IP folder. So again, it's a watch folder. As soon as a file hits it, it knows to send it to the next step in the pipeline. It's essentially the message we're getting is it's normalizing, and it's now converting the files to preservation and access formats. And this is again one of the critical components of the Archivematica system. Is the getting a message now that the AIP is getting prepared, the archival information package is getting prepared. So essentially, what we've done is. Our default preservation policy in the Archivematica system is to use normalization. So essentially, I think it's after all these years, I think we're still down to basically 4 primary strategies. It's technology preservation, keep all the technology running to keep your information accessible on the systems that created it. Emulation, so recreate the operating system application environment in which the digital objects were originally created, so that at some point in the future, you could emulate that environment and bring the original digital objects back so that people can read and use them at that point in time. Thirdly, it's migration, is that take all the stuff and keep a close eye on it. And if you think that some of the file formats are at risk, so that people will not be able to read and use them at some point in the future or the present, then go and migrate those to a format that you can view and use them on. Or normalization, which says right at the point that we get them, let's figure out what's our best bet for long-term preservation and convert the files to that format and make it available, make that our primary preservation format that we preserve it as. So Archivematica is for all three of the last. We support emulation, we support migration, we support normalization. So we'll always keep the original file format. We've got to cover our bets. So ideally, if the emulators, emulation technology advances, we'll always be able to pull up the original object to be able to emulate that. Migration is, we do normalization by default. So as stuff gets ingested, we see a file format, we map it to a preservation file format. If at some point in the future, 5-10 years down the road, we say, okay, we're not happy with TIFF, we're not happy with MPEG, we're going to migrate those to, then we'd have a migration alert, and the system would use the same normalization process to then do a migration and convert those files to the new preservation file format. But our default policy is normalization, and that is to convert upon ingest. And again, that's the default strategy used by the National Archives of Australia as well. And part of the rationale as well is that we figure we're going to have limited amount of time to actually pay attention to these SIPs as they're coming in. And it's probably at the point of ingest that we have the attention span of the archivist. After that, we just have such a large volume of information that we're never going to necessarily have the time and the resources to go back and do detailed migration analysis and so forth. So the point is, let's get as much done as we can at the point we're actually paying attention to the system, at the time we're actually bringing objects in. So a big part of our work over the last year is to define our media type preservation plans. So essentially to take specific file formats that we're going to expect to be getting in, and we started with the City of Vancouver and the IMF as our case studies, and seeing the typical files that they're getting, that they're expected to ingest over there, and trying to group them into media types so that we can standardize and have a preservation file format for a specific media type. And the other thing we're doing is we're creating access formats. So the OAS model it specifies that you would go and you create a dissemination information package when a consumer requests it, and you go and you get an AIP and you convert it and you give them the DIP, which just isn't very practical, I think. And one of the things, one of the family search guys from the Latter-day Saints did a presentation. They probably have the highest request per day for any kind of digital, if you want to call it digital archive system. They got all the digitized genealogy records and so forth. They're getting millions of hits a day. And they've applied an OIS reference model to their own digital archiving system, but they're saying this whole thing of like pulling the AIP off every time we get a request on our website is just not practical, and it really isn't. So the idea here is that we anticipate what we expect a good access format to be for the particular file format. At the point of normalization, we create both a preservation format and an access format, and that access format gets cached in the web access system, so that it's going to be able to take care of 90% of the requests we get from consumers. Will be met by those access formats. Of course, we still have a process. We still want to have a process in place where they can request the AIP and get at the original file format, for example. But again, we expect those to be the minority of cases. So what we're doing is, while we're defining our media type preservation plans, and trying to do it in a very practical way, is just sit down, figure out what file format we have. Do our research on what's a good preservation format, and that's been difficult to do. A lot of people aren't necessarily publishing or there's bits and pieces around, but it's not really in a systematic or structured way. Are people publishing their format policies? And that's been a bit of an issue. So we're doing a lot of work to try to assemble all that information. And access, for preservation formats, it has to be an open format, so an openly published format, ideally managed by some community committee or community process. It has to be a format that is able to preserve most of the significant characteristics of that file format. And in our case, a limitation we put on our own project is that we have to have a free and open source tool available to us that can normalize that format. If we don't, then it's not really an option for us, because one of our design goals is to be able to give this system away as a fully free and open source system. And that creates some problems for us, for example, in converting Microsoft Office documents without any kind of noticeable loss. So as an example, we've got the, so this is all on the Archivematica wiki. So this, if the page I'm showing you here, if you go follow the link to media type preservation plans, it shows you the overview of the file formats, what the preservation format is, what the access format, what tool we use to normalize it. You can drill down to each individual file format. There's a link to its pronom information until we have the universal format UFDR. Pronom is the best thing going we've got right now for kind of giving unique identifiers to actual file formats. There's a link to the significant characteristics. So for audio, the Florida Digital Archives has done a lot of good work on identifying essential characteristics in a very practical way. So we're borrowing a lot of their published information about their essential characteristics analysis. And so what we do is for each media type, we talk about what we consider to be the core essential characteristics. These are the characteristics that we have to be able to preserve when we go from the source format to the preservation format. Then we do actual tests. So we use tools. FFmpeg is a great tool for doing audio and video conversions. It's very well established in the open source community. So we run tests, we compare, make sure the tool does what we expect it to do. And then we set up an actual media type preservation plan for that particular media type. And this is all a work in progress, and it'll be a work in progress for as long as the Archivematica system around, which is going to be for a long, long time. But the point is that it's all accessible. Like we're making all this research. We're not saying we're perfect. We're just doing the best we can. And every time we make a decision, we try to document where we're getting this information from, whether it's by us running our own tests or pulling it in from other sources. And then we convert the media type preservation plan into an actionable configuration file. So by that we mean when you go into the Archivematica system, there's a folder called Format Policies, and for each file extension, there's a very simple format policy that captures the decision made for that particular release on the preservation and access format. So if you go to WMA, you'll notice that the very first value, it says inherit audio. And so what that means is that we could have a rule specifically for Windows Media Audio here, but in this case we said, okay, Windows Media Audio belongs to audio, and we're going to inherit the preservation rule we've established for audio. And likewise, what we could do here is we can then simply, if there's multiple variations of an extension name, we can simply point it to the one that's actually containing the rule. And here we go to the audio XML file, and you've got a very simple definition of what our access format or preservation format, and then the actual conversion command that Archivematica will pull out and apply to the normalization tool. So institutions can actually go right into this XML file if they want to change bitrate or other kind of values that they want to change. They're able to alter their own normalization and preservation format policies by simply editing an XML file. So we're doing our best to come up with default policies and say this is what we think is appropriate for Archivematica, but we're not locking anybody down to saying that this is the one that you have to apply at your institution. What am I doing for time? Looking good so far. Okay. And I think this is actually a very practical contribution that we're making in the Archivematica project. Whether it's useful to anybody else, time will tell. But again, in our own experience, is that it's great that we've got pronom out there, so we essentially have a registry to say definitively what's the correct name to use, the correct extension to use for a particular file format. We've got things now like the Planets project has the Plato tool and the test bed, which lets you do the similar testing that we've done, but in a much more, it's a bit more heavy duty in that it's done within a Java framework. If you want to test a tool, you got to build a Java wrapper for it. Us, we just go apt-get and it's there. And I can apt-get right from this USB key right now to do my test and record it in the wiki. It's slightly different approaches to the same problem. Two compatible approaches. So I guess what we'd like to do over time is actually contribute, and if it's useful, where there's gaps, we can contribute some of the tests we've been doing to that testbed repository. But after that, you've done tests. You say, okay, we've done these tests, and this is good. We lost some characteristics here. We lost some characteristics here. At the end of the day, the small and medium-sized archival institution just wants somebody to tell them, what do we do? Like, what do we do now? That's all great. It's very theoretically sound, but you haven't told us how to solve our problem. Like I got thousands of objects coming in. I need to do something with them. So what we're doing here is we're just explicitly publishing the preservation format that we've got for this iteration of Archivematica. in this case, in these rules here, we also what we're going to do is establish an external RDF registry so that the system itself can go query the external repository, and this is how we would trigger any migration processes. So if you look back at the high-level architecture diagram, you'll notice that under the monitor preservation service, it's going and checking the format registry, and all the format registry is essentially is an online repository of those format policies. And if there's any changes for a particular file format, the Archivematica itself will get that information back, and it can trigger a process using the actionable normalization rules to do a mass migration. At the same time, other projects can actually query that online repository well. And there's some really interesting work being done at the University of Southampton with the Preserve 2 project, where they're using linked RDF graph technology as well to go and compare and do risk analysis for different file format policies. But again, it's all at its very early native stage. But we're looking ahead and hoping to be interoperable with those kinds of initiatives. Okay, so going back to the workflow process then, we'll notice that the prepare IP process is finished. It's done all the normalization using the rules that we've defined here, and it's created a zip file using the Bagot format. So Bagot is both a specification and a set of, there's a number of different types of scripts. We're using the one from the Library of Congress, the JavaScript. And what it does is essentially, it's just a very basic specification. It just has some very basic rules about how we create information packages. It was originally designed for exchanging information packages between institutions, but we think it's ideal also for actually creating archival information packages. And the Tipper project is a collaboration between New York, University, Florida, and I'm missing one of them. But they're testing out some of this conceptually is to see if I have a Bagot file and I got it from my Fedora repository and I'm sending it to your custom-made repository. Is your repository able to ingest it and receive it in? And theoretically, that's what we should be able to do. So I'm really quite, I think, confident that Bagot is the best format we have today to start creating these information packages. There's a lot of research being done around it as well. And again, the whole point of it is it's simple, and that's really something that we try to focus on constantly. Is like, let's not over-engineer this. Let's keep it as simple as possible to reduce the layers of complexity to make it possible easy to get at the information at some point in the future. So what it does, it has a few rules about simply packaging up your information, having a manifest, having the information about what version of Bagot you're using, putting checksums in it, and then having a payload directory, which is called data, which in Archivematica we divide into the logs directory, where we keep all our raw logs, all the information about what's happened to information objects through the workflow, the actual objects, and then again our own manifest, which is a mets XML file. You'll notice that the data vibe job vacancy, the rich text format, has been converted to ODT, open document format. The Word documents converted to open document format. And in some cases where we don't have a good preservation file format, we just don't do normalization. We preserve the original. So this is for our Office documents example. This is our archival information package. This is the thing we're going to put away into storage now. It's again identified through UID. When we put stuff in storage, we want to use a modification of the California Digital Library's pair tree specification, which all it does is takes 2 digits of your identifier and makes that a subdirectory. So you can actually manually navigate the directory using just the ID to get at your package. We're going to do 4 because our UID is a little bit longer. And at this point, the system's agnostic as to what storage system is connected to it. So you notice here it's a linked directory again. At this point, this would be a shared directory that's either connected to, for the City of Vancouver, we're connecting it to network attached storage device. So it's just, to them, it's just an NFS share that they see as one giant directory where they put their stuff, and the guys in the back just keep hot swapping new boxes in as the terabytes get piled on. We give them a fright because we wanted 100 terabytes right off the bat. There's a lot of BANOC stuff coming in, Olympic Organization Committee stuff coming in, as well as the giant, one of the animation companies in the City of Vancouver basically donate a whole bunch of stuff, so it's terabytes of digital media. But the point is that from the archivist point of view, they don't want to manage storage. Archivematica point of view, we don't necessarily want to manage storage either. We just want to make it sure that we're compatible with as many types of storage, archival storage options as possible. So for my own home digital archives, I've got an Amazon S3 cloud storage account where I can split all the stuff into Amazon buckets. And for other situations, you can have it go specifically to external hard drives. We're very interested in looking at iROD's technology, having a data grid available to it, and using iROD's policies to then manage the geographical, because we have an issue now with Canadian archives interested in this kind of thing, but they don't want to use an Amazon S3 account because they don't want their data living in your wonderful country because of certain legislation that allows certain people to look at the data if they so desire. And that's not just an issue with Canada. I think it's actually, I've been talking to some people, it's just a comfort zone that most countries aren't willing to cross that border, so to speak. So in a lot of cases they're looking at, they like cloud storage, they like grid storage, but they want it to be national. They don't want it to be cross the national boundaries. And again, I think setting up an iRODS network is certainly a good option to look at for Canadian deployment. Okay, so that's the bit on storage. So it's off, let's just say it's off in whatever storage we've connected it to. At the same time that the normalization happened, it spit out the access copies into review DIP. So at this point, the archivist can have another look and decide whether there's certain files for, let's say, copyright or access reasons they don't actually want to put up into the access system. They can take them out at this point. But you'll notice here that we've normalized pretty much. We're dealing with Office documents, so almost everything is normalized to PDF. If it had been the multimedia example, most of it would have been MPEG for audio and MPEG for video. If it was the images, most of it would be JPEGs at this point. So our whatever type of SIP we have, whatever the media type is, it gets converted to the access format. So this is now going to get uploaded into the access system.
Peter, does a DIP know about its AIP?
Yes, it does. And in a very, very rudimentary way right now, one of our main deliverables for the 08 release is syncing the DIP and AIP information. So, but especially because we use the UID, the DIP knows about where its AIP is, but it's very, very limited right now. It's a very loose string. So we need a tighter integration between that. And of course, if somebody sees an object in the access system and says, now I want to request the IP, we have to have that process in place to actually go to get the IP and so forth. So that's when we build that piece, we'll tighten the integration between the two. But I do want to note that we do want to keep descriptive information in our descriptive system and technical metadata in the AIP. So we don't want to get into the business of taking, and we're having this debate right now, how much of the technical metadata, like you saw in the FITS report, right? How much of the technical metadata belongs in a descriptive access system, in a public access system? Well, somebody may want to search on resolution. Okay, resolution I could see, right? Somebody want to, or bit rate, but there's a whole list of other technical metadata that are pretty much useless that people aren't going to be searching on. And the same token, it's much easier to manage our descriptions in a descriptive metadata system rather than in zips, bagged packages in an archival storage, which in a lot of cases we're going to make like near line type storage as well. So there's once you start talking about terabytes of storage, it's a lot. We don't necessarily want to have highly available spinning disk storage, although that's nice to have, but it just becomes a cost issue. So I think there's a lot of logical reasons not to have everything synced 100%. Like everything that's in the APE is supposed to be in the DIP. I think from what we're kind of dealing with right now, we're kind of reviewing our requirements. Is that what can we put in the DIP? What can we put in the APE? And as long as the two are inextricably linked, that's acceptable to us.
Do you have to create a DIP?
No, you could stop right now.
And with just the
I could delete this right now, and then we'd be done.
And you could still search the store.
Yes, and that's what we're working on the dashboard, exactly. Right now we're looking at everything through the file manager interface. At some point, well actually we got it already. We have the basic prototype working for it. This is an earlier version, but this is the web-based interface, what we call the dashboard. So the dashboard will give you the opportunity to search the archival storage, search the dips and so forth. Almost all the log information will be accessible through. So that's all going to be like fully indexed and searchable through the dashboard. But the dashboard is not publicly accessible. This is the thing that the archivists use. And we want to put stuff out to a web access system, and the two are completely separate systems. And right now we're integrating with ICADM, but what we would like to be able to do is, because we're just using post, HTTP post and basically a REST API, so that you can start, like, we're talking to the Archon people as well, the Archon project, which is now combining with Archivist Toolkit, but we'd like to be able to have the opportunity to use that as your web access interface. And then, if somebody uses Content DM or whatever else, we want to be able to have multiple access system components. We want to be agnostic to what you want to use for your access system, because I think that's one of the other big hurdles to get across, is that people need the OAS processing piece, but everybody already has an archival description and access component. Most people do, they have their preference. So we don't want to dictate what that's going to be.
Are you recording relationship information when you create preservation copies? Derivations?
Yes, yeah. Well, it's not in there now, but it will be in 07. That's one of the more detailed technical data we talked about. Right now, the connection is purely by the identifier. So by following that connection, then you get the metadata over there, which tells you all the derivations that have been made. And that is something I think arguably should belong in the descriptive system as well. So you say, hey, you're looking at a PDF, but by the way, this came from a Word document. So what I've done now is I've dragged it into the next watch directory, which is upload dip. And I'm running a local copy of ICADM here, but for the same intensive purposes, that's running somewhere completely over the web. And in this case, the Dublin Core XML metadata that came with the SIP and the part of element identified what font you guys use record groups, what record group it was part of. So it knows as it's uploading, it knows that, hey, we got one sample record group in here right now. And so we've told it that all of this SIP is essentially part of that particular record group. So it's going to find it and attach itself to it. Otherwise, it would just create a brand new top level collection, essentially. The level description by default is set to series right now. So Archivematica is uploading the various files to this phone right now. We don't see any of it because, oh, there it is. I'm still logged in. See it coming in. ICADM has a publication workflow. Oops. Which essentially allows archivists to create descriptions, and while they're working on it, it's not accessible to the public search and browse. So while it's getting uploaded, it's not available. It's set to draft. But this is using the title from the Dublin Core XML that came in, and we got validation now as well. This is an ISAD description. You see at the top. So it's telling the user what elements are still required to do a proper ISAD description. If you notice here, the various files are getting uploaded. If it had a multi-page PDF, it split it all into multi-pages for browsing. The cover flow viewer starts to show all of the documents as they're coming in. And we took whatever metadata we got from the Dublin Core XML file, but again, we like to use EAD for that to make it take in as much rich archival description as we can if it's already been created. And then for each individual system, we'll have to do a mapping where we say this is the metadata that comes out of your particular ERDMS or whatever other source system you have, or this one legacy data migration project we're doing for your shared directories, and this is the metadata we're able to pull off of it, and we map that to these archival description elements for purposes of when it gets to upload it to the archival description application. And then once it's inside Archivematica, inside ICADM, then we can essentially carry on with our archival description and add all of the various elements that are available to whatever standard we're using. So we can switch templates in ICADM by go from ISAD to Dublin Core. We've also got the rules for archival description. And by default, we'd like to have DAX in there as well for the US users. It's very close to ISAT, so that's not a big stretch. So it's gone out of the upload folder, so all the files should be here now. Refresh that. So we're looking at here is the metadata that came along for the ride, just a few little sample elements. The archivist now can carry on and do full archival description. So again, how much this, like this, in this case, we're using the ISAT templates, and I can do things now like instead of series, I want to make it a sub-series, add any of the elements for this particular, at this level, at the SIP level, or at the item level. I'll also change the publish status, so as soon as I do that, so the archivist has time to look at it, take stuff out, add descriptions, and then when they're happy with it, they can publish it. Now it becomes available in the search and browse index for the public.
Peter, if your SIP had metadata, say from TRIM or some other records management application, will it pull that?
Yeah, that's what I was talking about. We have to define profiles. Like we're going to have generic profiles to say if you should. Our submission agreement is that you give us Dublin Core XML or you give us EAD XML. If you do, we know how to handle it. Or we say for TRIM, we know TRIM spits out this kind of metadata, so we're going to take it and this is what we're going to do with it. So we have to like system by system. And ideally, what happens is at a project like City of Vancouver, we create a TRIM profile. TRIM is used a lot of different places. We had some Malaysian archivists visit; they're using it, for example. So the idea is we create it once. As soon as we created it, it becomes available as a profile that ships with Archivematica. Next time somebody has a Documentum or whatever interface, we create a profile for that, and whatever project we have or a user out in the field creates that and contributes it back to the project. So there's no way we would know without, there's ways we can make a generic profile to say this is we expect Dublin Core and EAD, and if you do, this is what we're going to do with it. And otherwise, we have to do an analysis for each various target system that's contributing content. So here, so we're able to do arrangement and description once it's inside the system by dragging and dropping in the hierarchy tree. Where did I drop that? There it is. And then do things like export as Dublin Core or EAD after I've added description and so forth. That's pretty much it. Like that. This is where Archivematica 06 is at right now. This is the release we finished last week. We essentially came out of a proof of concept. Like until a year ago, we weren't sure whether this was going to fly. We're just like, well, there's nothing else going on. So in the meanwhile, we got to do something. So let's see. If the idea of the concept was, can we stitch together all these tools to make something work? And the good news is that it's working. Like we're able to do it. We're confident now that the archives there is confident that we can be compliant with OIS. We can create archival information packages, put them away for long-term storage. Using the tools we have now, even in this very, very early raw prototype system. Until 05 was essentially proof of concept. Now we have this raw prototype you can actually put down in front of an archivist and they can get some work done. So there's a lot of stuff we crammed into 06 release. Asking about ingest, we want to make sure that we can properly take in Bagot SIPs as well. So again, if we're getting stuff from other systems, or kind of standardize on Bagot as our SIP standards. So not just standardize on the metadata, like it would be nice to have qualified Dublin Core or EAD. And then the way you put it all together, we'd like you to put it together as a Bagot. That would be our preferred submission information package. And if not, then we will create templates to map to whatever you're sending us. The other big one is moving all log data into premise elements and then completing that work, doing work on the first iteration of that web dashboard I showed you the screen capture for. And then the big one for 08 we mentioned was getting the syncing between the access system and the archival storage. And we're still making decisions there about what's our default metadata that we want to share between the two. And having a way to manage threaded processes. So from the dashboard, we want to be able to say, like right now, we're using lock and queuing utilities, which is great. So I can throw a bunch of SIPs at the system at once, and it'll queue them, and it won't choke on them, which is great. But now we want to be able to have it so that we have multiple nodes. Like let's say I have 3 or 4 archivists working on ingest at the same time. And we want to be able to and we got, so if we're doing the video conversions, like the animation company extension I was talking about has very large video files. So we know that machine's going to be busy for the next 6 hours converting this giant video file, for example. So we want to be able to start, the same archivist wants to keep continuing the process as SIP, but be able to thread processes on various machines. So that's something that's pretty advanced step we can do to essentially make it a production-ready system that can handle high volumes of ingest. And that's the other big thing we want to work on. And of course, the preservation monitoring piece. Like, we already got a bit of a prototype up for the format policy registry I was talking about, but we want to actually incorporate that into the working system. So, since we started this project now, there is a couple of vendors that are offering similar type solutions. So essentially, ones that are specifically talk the OIS language and are meant to do the same thing, taking information packages from ingest to access. But the one difference between Archivematica and now is that we're a fully free and open source project. And what that means is the project is free as in free beer. So if I buy you beer, so I don't know if you heard that analogy. So if I can buy you a beer and it's free to you, it didn't cost you anything. There's no monetary charge for you. Most importantly, though, it's free as in free as a dove. So free software. There's 4 fundamental freedoms that are at the core of what free and open source software is, and these are defined by Richard Stallman, who wrote the GPL license. There's variations of this, and there's various open source definitions, but the 4 core freedoms is that you have the freedom to download this software and run it for any purpose. You have the freedom to study it, and essentially figure out how to adapt it to your own needs. So here's Archivematica, here's the default, here's what we did with it. See what you can do with it. If you want to make customizations to it, you want to do something different with it, you're more than welcome to do it. And a critical piece of that is to give access to the source code. So there's a lot of projects around that say they're free and open source, but then you can only download a tarball, or you can download an executable file that they've built with their own system, so you can't get at the source code. So I think free software, in order for free software to be free, is you have to have easy access to the source code. You're allowed to redistribute it to anybody or society in general for society's benefit, and of course you can improve it and contribute it back to the community as a whole. There's no such thing as a free lunch. It always costs money to run technology, including free and open source software, including Archivematica. The big thing is, though, we think we can improve quite a bit on the total cost of ownership, especially for the archival community where there's limited budgets. So I think the best analogy is kind of like a free kitten. So it's free to you, but you got to pay to feed it, but it'll grow up and it'll grow to love you and sit in your lap and purr, and you'll have a good relationship with it. So the point I want to end on is that I think Archivematica is in its very early stage, but I think we've already proven that we're onto something, and I think that we can, in a very short period of time, with very, very limited resources, we've been able to put together a good raw working prototype, and within the year's time, we expect to be at a point where we have production ready, we expect systems that are able to go into production ready digital preservation processing. The big key difference, again, is that I think we're able to maximize the limited amount of funding and resources that are available in the archival community, where there's a lot of the early development done by lead institutions, essentially that have all the knowledge about what archival preservation is, hire a contractor, they pass a lot of knowledge on to the contractor, they painstakingly co-develop digital preservation solutions over a period of years, and then can't share that technology or that technical knowledge with the community at large because the contractor now has a license on it, and they'll resell it back to the community. So that knowledge that, it's essentially public money being spent to create technology to preserve public records for the public trust, but it's not in the public domain. And I, personally, have a problem with that. As a taxpayer, I have a problem with that. Of course, as an open source software developer, it's also my business model is to offer an alternative to that. And so, one of the big things we want to do is encourage as much participation in the project as possible. And there's multiple ways for us to find partners and collaborators. And the open source business model is one that's very legitimate these days. There's lots of success stories, lots of places where it works. But I think in particular for the archival community, where we're dealing with essentially the problem, one of our major problems is obsolete software, incompatible software, proprietary software. So it's a little ironic that we would be funding solutions to create proprietary solutions for it. That's my open source spiel. So I hope that's my little bit about open source software, and this is why I think open source software is at least at the very least, I want there to be a legitimate open source alternative for archival institutions, and that's part of the rationale for one of the driving points behind the Archivematica project is to build a solid core of software code that works well. It competes just as well with proprietary products, but also it becomes a base for sharing knowledge within the community and building that community. And there's lots of pieces to the puzzle. A project like this in our case started with us as a service provider. In some cases it starts with lead institutions. And as the projects mature, typically they'll establish some kind of foundation or steering committee. And this is exactly the kind of ecosystem now we're looking to build around the Archivematica project. So if you want to get involved, learn more, that's where to find it. The website where to find more. Thanks for your time. We'll take more questions if we have time.
I have another question. We go back to the beginning. You said the markable object is a file. Comes in a zip. But you're also equipped to deal with shared drives. So if the content of the shared drive is an end user's files, as opposed to something coming out of trim or some other RMA, the default arrangement of those files is the paths that the user established. Does Archivematica preserve information about that structure?
Yeah, it keeps the same structure. So one of the initial debates we had was whether every file is a SIP or every file is an AIP, and it just wasn't practical. And the OS specification is flexible on that point. And we tried getting some debate on ERXL about it and that kind of stuff, but none of people were talking about it. So, but at any point, the design decision that we made is that whatever the user drops down as a SIP, and that can multiple files with nested directories, that's what we maintain as the AIP. So, and this is part of the design decision up front when we do integration with existing systems. Is like, what's a reasonable size for how many files we want to SIP, or what's the rule for creating a SIP, the logical arrangement. So for the electronic records document management system, it's all the files within the same classification code that have the same retention rule. That's the stuff that comes in as individual SIPs. In your example, you say, okay, I'm going to drag and drop all of my documents directory with all its various nested directories, all the rest of it. If that's what you drag and drop into received SIP, Archivematica will start processing that as a SIP as one giant information packages with multiple information objects, multiple files within it. It'll treat it, or you can parse it down and say, okay, I want to take these objects and so forth, but it'll respect whatever nesting you've assigned to it right from the beginning. So, but again, from a logical point of view, you probably don't want to have 100 directories with several thousand files as one giant information package. It just makes it more difficult over time to manage as archival information packages and so forth. But at this point, it's like totally agnostic on what you decide to feed it.
Peter, what would you do with a web crawl? I saw you had HT-Track on there as one of your tools, and you are going to have multiple levels of hierarchy and file formats all over the place.
And that's what we decided to do with the web crawl. Like, I don't know any web archiving project where they actually have somebody go through and rearrange it after the crawl. So, and it just is too time intensive. So yes, that's a really good example of the one, like, similar to what Ken was saying. Like, we will take the entire web crawl, starting at the root URL, which is a tool like HT-Track converts it all to nested relative directories, and we will take that in as the SIP. Does that answer your question? I think it's silence. Yeah, I know. To be honest, we haven't done much testing with it yet, so we don't know at what point or if it will choke. Whether it's, but we, at this point in time, that's our design decision. Any feedback on that? Was that Richard? Or was that Mark?
It's Mark. We've got quite a few web crawls sitting on our test bed. One of them is, for example, the Columbia Access Investigation Board website, which has somewhere in the neighborhood of 4,000 files in a dozen formats. And I forget how many levels of hierarchy.
Yeah, 4,000 files seems okay to me. Like, I think we'd be okay with that. It's just more cycle time, processor cycle time. It just might take a long time to crunch through it all. I don't think that'll be a problem. I mean, that's a small website. What do you think? Like 4,000 files?
Yeah, that's relatively small.
Yeah.
But what do you do with the normalization?
The normalization, it's just going to go side by side with the original format. and it's going to get mapped in the METS document, and then we can apply rules and logic to the METS document later on to, like, you know, it'll create the file groups, you know, the METS in the file section, and that we can use that to map, use its use attribute to decide, you know, to figure out which was the original, which was the normalized copy. So it's you know, we are applying preservation formats where appropriate. So that's one step better than where you just do a crawl and you put it away, that directory away into storage. Or, like, you know, you do a crawl and I think, correct me if I'm wrong, but like the Heritrix approach is, you know, you do the crawl and you essentially stuff it into an ARC file as a compression package, but you're not really doing any preservation on the actual files that are coming back from the crawl. Is that right in your experience? Do you have much experience with the Heritrix approach?
I haven't played with Heritrix. I have played with HT-Track.
Yeah.
And just the way you maintain links, you know, depending on the settings that you use on HT-Track, you'll get some very different results. And you'll also get very different results in terms of what you can disseminate from that.
Oh yeah, absolutely. So there's like a black magic to getting HT-Track to work the way you want, and a lot of days invested in it usually. But we still like it as, you know, as the only option. Like, for example, the reason we integrated it was because we wanted to crawl the Vancouver Olympic Committee websites because they were going to go down at some point. So we got to do something. What can we do today? Well, we can run HT-Track at it. So a couple of the archivists at the City Archives played with the settings for quite some time to get it to the point where, you know, we're happy with the scope, what we're getting back. And now we know we've got something. We've always got that original crawl. We're gonna run it through Archivematica, so we've got some normalized access copies. The settings you can use it to create a completely relative website. So when you start with the source page, you can, as long as there's hyperlinks to the nested pages, you can follow the hyperlinks around. Of course, JavaScript and search indexes won't work, but the site itself is preserved. Presuming that you've got file readers for all the various file content that was on there, what we would be able to do with using the METS, the METS document, would be able to say, if you hit one of these, you know, create an alternate mapping, so that if you're going to hit files, let's say it's 10 years down the road, and you're going to hit, you know, certain files in there that we know we don't have good readers for anymore, or file versions, we could use the mapping in the METS file to swap those out with the ones sitting side by side. So it leaves us more options. I'm not saying it's a complete solution, but it's as good as anything else out there as far as I'm concerned.
Okay, thanks.
I don't want to get too far into the weeds, which is usually a warning that I'm about to.
I got lots of time, so I don't know my colleagues.
I was wondering if you had any thoughts on the tools, approaches that you might use with probably withdrawing material and redacting material that you publish.
Withdrawing material? So you mean like scalable vector graphics?
No, I mean withdrawing material.
Oh, withdrawing, pardon me. Okay, yeah. Well, I think that would be, we would leave that open to the access system. Mm-hmm. So, and like, for example, with the IC Atom, we're able to leave stuff as unpublic. First of all, you get to decide before you upload whether you even want to upload stuff altogether. If you have problems with, there's access issues, you wouldn't upload that to your access system anyway. Mm-hmm. And in that case, we probably integrate a redaction tool at that point and redact it before it gets uploaded to the access system is probably the way we'd want to do it. For the time being, like we typically have access policy set at the series level or at a higher level, not at the item by item level, but I know that's not always the case. So we would withhold like publishing the, we might have the descriptive metadata, but we might not upload the digital objects if that's an issue. But it's something I don't necessarily see, other than integrate, again, maybe adding a microservice but we probably wouldn't even make an Archivematica microservice. We'd just make it a stop where you would then be able to apply a redaction tool and do what you need to do before you upload it. That's probably how we'd handle it. But it hasn't been an issue yet. We haven't spent much time thinking about it.
Okay, thank you.
Very good. Thanks everybody for for your time.